Hello everyone, again this is teacher Wendell and now we will continue our trigonometry series under the topic angles and their measures. So we have studied last time the definition of trigonometry. Let us review a bit. Trigonometry is a branch of mathematics that studies triangles and the relationships among their sides and angles. So this is the main concept of trigonometry. It studies triangles and the relationships among the sides and angles of those triangles. And we can study trigonometry using two different approaches, using circular functions and using trigonometry functions. So welcome to the part 2 of the angles and their measures topic. So remember, angle is the amount of turn between two lines that meet each other. So the common endpoint of the two lines or the two rays is called the vertex. The angle is the amount of turn or the space between the two lines or the two rays. And the two rays are called the arms. And we also have this formal definition of angles formed by two rays with a common endpoint. And the stationary ray is called the initial side, and the rotating ray is called the terminal side. So this is the initial side where you start measuring the angle, and the terminal side where you end or you stopped measuring the angle. So it's easy to identify where's the terminal side because of the arrowhead. The arrowhead always points and touches the terminal side. So we will now study about angles in standard position. When can we say that an angle is in standard position? So very simple concept here is, if the angle is at the origin, what does it mean? If the vertex is at the origin, it means the vertex of the angle is at the point 0, 0, and the initial side of the angle is on the positive x-axis. So these are the two conditions for the angle to be in standard position. First, your initial side must be here in this line, not here, but only here on the positive x-axis. Next condition is the vertex is at the origin or the point 0, 0. This is another example of an angle in standard position because the initial side is here on the positive x-axis and the vertex is at the origin. So even if it is a negative angle, it is still in standard position. And how do we identify positive and negative angles? The sign of an angle depends upon the direction of the angle's rotation. The angle is positive when the rotation is counterclockwise or anti-clockwise. It means opposite of the direction of the clock. And the angle is negative when the rotation is clockwise. Again, let's look at these examples here. This angle is counterclockwise, so this angle must be positive. But this one is clockwise, so this angle must be negative. So more examples are here. Positive angle going up or counterclockwise direction from your initial side. And negative angle is going to the same direction of the clock, so it's negative. Let's have a practice. Give the angle, and you have to give your answer in degree and radian measure. So if you still are not master with converting degree to radian or radian to degree, I will be giving you another tutorial for that, another video to review how to convert degree measures to radian measures and vice versa. So we will have here an example of finding the angle, which is represented by the following. And it should be rotated from the positive x-axis. It means the angle will be in standard position. Number one, how much is half of a rotation clockwise? Okay, first of all, you need to understand that one rotation is like one whole circle or 360 degrees. So half of it is 180 degrees. But look at the direction. It is clockwise. Remember, if clockwise, it's negative. So the answer is negative 180 degrees. or negative pi radian, or negative pi only. Okay, 180 degrees is 1 pi radian, so negative 180 degrees is negative pi. Next, how much is 1/6 of a rotation anti-clockwise? So it is anti-clockwise, so opposite of the direction of the clock, so the angle will be positive. Okay, we will give a positive answer here. And how much is 1/6 of a rotation? 1/6 of 360 degrees is 60 degrees. So the answer is 60 degrees, or pi over 3 in radian form. Again, 60 degrees is in degree form, pi over 3 is in radian form, but they mean the same angle. Okay, number 3. How much is 1.7 rotations clockwise? So simply multiply 1.7 by 360 degrees and look at the direction clockwise. So it should be negative. Again, 1.7 times 360 is 612. Put a negative sign because your angle will be negative because of the word clockwise. So it's negative 612 degrees. When you convert it to radian form, it must be negative 17 pi over 5. Number 4. What is the angle 3.35 rotations counterclockwise? Again, it is counterclockwise, so the angle must be positive. And what is 3.35 times 360 degrees? The answer is 1,206 degrees. Okay, so 3.35 times 360 degrees is 1,260 degrees. You may use your calculator to check this answer. And then if you convert it to radian form, it is equal to 67 pi over 10. So if you are not master with this lesson, you can comment below and I will make another video about changing degree to radian or radian to degree form. Number 5, how much is the angle 5 rotations anti-clockwise? Now anti-clockwise means the same thing as counterclockwise. So the angle will be positive. So what is 5 times 360 degrees? It is 1,800 degrees. Okay? Or 10 pi radian. Now let's go to the concept of quadrantal angles. Remember class, a Cartesian plane or an XY plane can be divided into 4 parts, okay, which are called the quadrants. Okay, starting from the upper right side, that will be quadrant 1. Then upper left side will be quadrant 2. Lower left side will be quadrant 3. Lower right side will be quadrant 4. Those are the 4 quadrants of the XY plane or the Cartesian plane. So when can we say that the angle is quadrantal? This is the thing that you have to bear in mind. If the terminal side of an angle lies on an axis, it says an axis. It doesn't specify either x-axis only or y-axis. As long as it is an axis, meaning it could be the x-axis, it could be the y-axis, it could be the positive x-axis, it could be the negative x-axis, it could be the positive y-axis or negative y-axis. Then the angle is a quadrantal angle. So if the terminal side or the end side of the angle is on the line x-axis or y-axis, then that angle is quadrantal. So what are those quadrantal angles? 360 degrees, because the terminal side is on this line, the positive x-axis. 90 degrees is also quadrantal because it's on the positive y-axis, the terminal side of the angle. 180 degrees ends at this line or the negative x-axis. That is also an axis. So it's also a quadrantal angle. And the angle 270 degrees. It ends at this line. This is the negative y-axis. Okay, so remember the 4 quadrantal angles, 90, 180, 270, 360 degrees. 0 is not a quadrantal angle. It's 360, not 0. Because 0 is doesn't have an opening. It is 0 degrees, meaning it doesn't turn. So there is no terminal side. It has only the initial side. Okay? Now, let's go to the concept of coterminal angles. Remember the word terminal? Terminal means end, like end point. Like when you say the terminal, it's the terminal of the bus, meaning it's the end destination of the bus. Okay? Or the train. So coterminal means two angles are said to be coterminal if they are in standard position. That's the first condition. Again, standard position means the initial side is on the positive x-axis and the vertex is on the origin or the point 0, 0. So two angles are said to be coterminal if they are in standard position and have the same terminal side, okay, or they share a common terminal side. And coterminal angles differ by an integral number of revolutions. So since one of complete revolution is 360 degrees, any angle theta can be written in the form theta plus 360 degrees times n, where n is an integer. So this black font colored text is a formula to find all the coterminal angles to an angle theta. So your angle theta will be the given angle, and you use this formula to find the coterminal angles. It means there are many, infinitely many coterminal angles to one single angle, because your n can be uh, any integer, can be 1, can be 2, can be 3, and so on. It could be -1, -2, -3, and so on. So if you use those numbers, you will get different values. Okay, so you will get many coterminal angles to one angle theta. So to illustrate that, let us have this example. The two angles positive 30 degrees and negative 330 degrees are coterminal because positive 30 degrees ends at this line, the blue one. That is the terminal side. And also the negative 330 degrees. The terminal side of that is also this line, or the blue line, or the blue ray. And both are in standard position. Both started at this red line, or the positive x-axis. Okay? So 30 ends here, negative 30 ends here. This is their common terminal side. So 30 degrees and negative 30 degrees are coterminal angles. Another example is 150 degrees and negative 210 degrees are also coterminal angles. Okay? Because of this. 150, starting from the positive x-axis, will go here and end at this line. Also, negative 210, go to clockwise direction from this positive x-axis. You will also end at that line. So that is also the terminal side. So these two angles are coterminal. Now, can you give your own example? So I want you to think of your own example of two angles that are coterminal. Again, we can find other angles which are coterminal to the angle 150 degrees. Using the formula theta plus 360 degrees times n. In this example, our angle, our main angle, or theta, is 150. So using the formula theta plus 360 degrees times n, if we use an integer of 1, so we will get 510 degrees. If we use an integer of 2 here, if we change n to 2, because n stands for any integer, so if it is 2, it will be 150 degrees plus 720, so 870 degrees. But if we use a negative integer 1, it will be 150 minus 360, so that's negative 210. You will get this angle here in the example. Or if you use negative 3 for your, negative 2 for your n, you will have 150 minus 720, or negative 570 degrees. And if you use a negative 3 for n, 150 minus 1080, you will get 930 degrees. So as you can see, there are many different coterminal angles to a certain angle. You can have positive coterminals or negative coterminals. So let's go now to the concept of reference angles. So what are reference angles and how to find them? A reference angle is an acute angle between the terminal side and the x-axis. Okay? So acute angles are angles between 0 degrees and 90 degrees. So a reference angle should be acute, should be positive, less than 90, more than 0, and the angle should be between the terminal side of the angle and the x-axis. So reference angles can only be 0 to 90 degrees, or between 0 and 90 degrees. So these are illustrations of the reference angles. So our angle theta in green, that is our given or main angle. The red one, theta prime, that is the reference angle. Okay? So let's start in quadrant 1. The example here looks like an angle which is 45 degrees because it's half of 90. So as you can see, 45 degrees is the standard angle. The reference angle is also 45. They are the same. So in quadrant 1, the standard angle and the reference angle are equal. Now let's go to the example in quadrant 2. The angle in quadrant 2 to the green one, the theta, looks like 135 degrees or 90 plus 45. But the reference angle, according to the definition, should be acute. This is more than 90, so this is obtuse. The acute angle will be this one. So to find the acute angle, the easiest way is find the terminal side, terminal line. So this is the terminal side of the angle. From that line, go to the nearest x-axis. The nearest x-axis is the negative x-axis. And that angle must be acute or less than 90. How much is that angle? 45. Okay, so that is the reference angle of 135 degrees. Only this angle. Do not say negative 45. It should be positive. Positive acute angle. In quadrant 3, we have an angle here which looks like 240 degrees because it looks like 180 plus 60. So 240. The reference angle is only this red one, which is about 60 degrees. Okay, that's the only reference angle. Because from the terminal side or the line where the angle ends, go to the nearest x-axis. And that is the reference angle, or 60 degrees. Last example, in quadrant 4, we have an angle that looks like 315 degrees because it's 180 plus 90 to 70 plus 45, so 315 degrees. So the green one is the standard angle, 315 degrees positive. The reference angle is only 45 degrees, only the red one, the small angle there, because from the terminal side, from that line going to the nearest x-axis, which is the positive x-axis, this is the angle, that is 45 degrees. Again, a reference angle must be acute, must be positive, and it should be the angle from the terminal side of the angle going to the x-axis. So these are some other illustrations of reference angles. So the angle 220 degrees has a reference angle of 40 degrees because 220 minus 180 is 40. This is also the given angle, blue one, the reference is only the red, also here and here. Now let's go to the practice to test your understanding of reference angles. Give the reference angle for each of the following. Number 1, what is the reference angle of 60 degrees? Yes, it's 60. Because it is already in acute angle form. So that's the answer. And it's positive. Number 2, how about negative 60 degrees? Yes, it's also 60. Simply change it to positive 60. Okay? So, because 60 is acute. To make it the reference, make it positive. How about number 3, 135 degrees? So 135 degrees has a terminal side in quadrant 2. That's 90 plus 45. So the reference angle is only 45 because from the terminal side going to the nearest x-axis, which is the negative x-axis, the angle is 45 degrees. You can try these problems by yourself, okay? Or you can find more problems on the internet on finding the reference angles, and you practice by yourself to master this topic. How about 200 degrees? What is the reference angle? 20, because that is 180 and another 20 degrees. So that 20 degrees is the reference angle. Okay, the easiest way again is to draw. Okay, so for number 1, you draw 60 degrees from the line where the angle ends or the terminal side. Go to the nearest x-axis. That is your reference angle. Also with the rest of these examples. How about number 5? 405 degrees. What is the reference angle? The reference angle will be, it looks like 405 is more than one rotation. So you subtract one rotation. which is 360. So 405 minus 360 is 45. And that 45 is acute, so that is the reference angle. Okay, 405 minus 360. Number 6, negative 250 degrees looks like negative 180 and another negative 70. So the angle is 70 degrees. Again, you can draw the angle, draw 405 degrees, and then from the terminal side, find the angle going to the nearest x-axis, and that will be your reference angle. Last problem, 700 degrees. 700 degrees is one rotation plus 340 degrees. So it's almost going back to 0 degrees. So you need 20 degrees more. So that is the reference angle. So reference angle is 20 degrees. So this is the end of part 2, okay? Or the second part of our angles and their measures tutorial. So if you have some comments, questions, you can comment down below. And I will make another video for that. Okay, so I will see you in the next video.